Hi, this is Swapnil Bhatia, and in this special edition of Red Hat Summit remotely that we are covering here, today we have with us Rich Sharples, Senior Director of Product Management at Red Hat. First of all, Rich, thanks for coming on the show. We were supposed to meet in person, but because of this crisis, we have to do it remotely. So I'm actually happy with all the technologies around us that it still allow us to still do all these things which were otherwise not possible. And most of these technologies are running on open source technologies too. So let's talk about Java, because I think, if I'm not wrong, Java programming language is going to turn 25. So what I want to know from you is that over the course of these 25 years, I mean, if you look at Java, I mean, when I look at my DVD player, it has Java, it's running on Java. A lot of people don't even know those things. So if you look at the evolution of Java all the way in 25 years, today we talk about cloud native, everywhere, microservices. So what I want to understand is that over all these years, how Java evolved from those kind of workloads to these kind of workloads. And what is there that it has been so successful throughout the years?
Java's early success was down to a couple of things. One is that it was not a single vendor producing it. So those Sun Microsystems was the creator. They created a very large ecosystem with other vendors like IBM and Oracle. And that allowed an entire industry to grow up around Java. There were some technical aspects that made Java a really good fit for, if you think 25 years ago, the kind of birth of the modern web. It was really the first language that had primitives built in for building network applications. It was a much safer and easier to use language than its contemporaries like C++. A little bit later, some of the popularity was really boosted again by its inclusion in mobile Android with the Dalvik JVM, which is essentially Java running Linux. And within the last kind of 10, 12 years, it was open source, truly open sourced. It was always a very open development model and definition of the language standard, but open sourcing the actual code was a huge boost as well. And then more recently, as we're kind of moving towards cloud native and new development and deployment paradigms like serverless, function as a service, containerized applications, there are a number of projects out there to really ensure that Java remains the kind of key language for enterprises building mission critical applications. So over its evolution, it's managed to do a number of pivots and take advantages of new waves of technology and thinking, and it's been managed pretty well.
Java has been seen as a very massive monolith, huge, code. And when you look at the modern workloads, cloud native workloads, they are like very lightweight. So I was talking to Java team, when you did Java team, as you rightly said, I was talking about Oracle, and they're like, the way Java was designed from the early days, you're supposed to run on very lightweight, client machine. Your server may be heavyweight, but the machine you're in. So can you also talk about, how that even if, cloud was not even a term when Java was actually created, but the language, was kind of, designed for such use cases that it fits very well.
Yeah, so Java was originally designed to run on low profile devices, toasters, DVD players, set-top boxes, that kind of thing, mobile. Originally was very well suited for those environments. But as its popularity grew, it really found a very large niche as a server-side technology. So running large complex websites, backends for airlines and banks, and that's where its real success was for many decades and still is. So Java really is the workhorse of the enterprise, running very complex applications, large scale, with very small tolerance for downtime. As such, a lot of focus was put into that kind of environment where an application could really use as much resources as possible on a machine, memory, CPU, network, and over the years it was tuned and optimized for those kinds of environments. Now, Fast forward 25 years, we're in a world where your application is lucky to get a slice of a virtual machine. We're in a fairly resource limited environment. Something like functions as a service is an extreme example of that, where you literally don't even get a slice of a machine. You just get as much CPU and memory as is required to run your function a single time. So, we are having to rethink some of the strengths of Java, rethink how it's been architected internally, and come up with new ways of thinking about deploying and running applications in these new environments. And that's where a project called Quarkus really fits in that we've been working on for the last couple of years.
Yeah, can you talk about some of the efforts that you made within Red Hat, like the Eclipse micro profile, which was I think announced like a couple of years ago at Red Hat Summit, and also as you mentioned, you don't even get a slice, you just get as much resources that you need. So can you talk about some of the work that you are doing, also part of Project Quarks?
Yeah, absolutely. I mean, if you imagine your existing monolithic application running as a single JVM process on a big machine, if we then take that same functionality and break it down into discrete microservices, and every microservice gets its own JVM, all of a sudden my memory utilization has gone up, because the Java virtual machine does take a lot of memory. It does some incredible things. It's able to optimize itself as it's running. It's a very dynamic language. I can load in new code and replace code as I'm running. It does some truly incredible things, but they come at a cost, and that's generally additional memory. So as I think about microservices and functions, what I really want to optimize for is startup time. I want to start up instantly and be able to handle requests straight away as soon as my pod or container is active, or my function. And I want to use as little memory as possible. I don't want to give a lot of overhead to the actual runtime environment. I want to save that for my code and my data. So what Quarkus does is it kind of really rethinks that environment. So if you think about what a typical Java program does, it does a huge amount of very, very clever stuff, loading classes, loading whole networks of classes, scanning classes, bringing in configuration, scanning the configuration and load it into memory. And once it's done all that, it never has to do that again, especially in a microservices environment. Because if I want to change anything in a microservices cloud-native environment, I just kill the pod and restart. So I don't need to do all of that dynamic stuff, other than at startup. So once I've done it, I'm still carrying all of that code and complexity around with my runtime image. So the way we think about it in Quarkus is, well, can we do all of that initialization at compile time and do it once and once only? And then we don't carry that code and memory overhead into my production environment. So that's just one example of how we've kind of reimagined how applications will run in this cloud native environment. So as a result, we can get much, much better startup time, hundreds of times faster potentially, and radically reduced memory usage.
So if you look at alternatives, or Quarkus, how differently are you looking or addressing the problem than they are?
Yes, there are other projects. We have Micronaut, Spring Boot to some degree, Graal VM and Substrate. Are all trying to address the same issue, that we do need to bring the resource utilization footprint down for Java. The approach we've taken is I think a little bit more holistic. We are looking at the entire cloud native way of doing things, right? So yes, I need less footprint. Yes, I need lower memory usage and faster startup time, but I also need to adopt to different programming paradigms. When we're developing cloud-native microservices or functions, we typically think of event-driven architectures, handling streams of events. So it's important to be able to handle both reactive and traditional imperative programming, which Quarkus does. It's really important to have a really, really tight inner development loop. When I'm developing on my own as a single developer, we have this really, really nice ability to live code, to change the code literally as I'm running, and change the code and try your test again and see what the outcome is. So we focused on different programming paradigms, and we focused on the end-to-end developer experience, because at the end of the day, what I'm producing is a container image that I can run in Kubernetes. That's the output of my development. So bringing that full kind of life cycle together is super important as well. That's what we've really focused on. The resource utilization optimization is necessary but not sufficient to make this a great experience for cloud native.
Can you talk a bit about the project itself? It's a Red Hat project, so I also want to know about what does your release cadence look like? What is your governance model around it? And most of the not most, almost everything that Red Hat does is open source, so that is not even a question there. But also at the same time, what does the next release look like?
You're right. It's an open source project. You have a very easy Apache license. We are absolutely open. I mean, typically when we start new projects, we have this kind of old adage that if you want to move quickly, move alone. If you want to go far, go with others. So initially it was developed by Red Hat with a small team so that we could move very, very quickly. It's taken us about a year to get a GA release. Now that it's established and we have the kind of baseline capability established, we are certainly looking for partners to kind of help take it to the next level. So definitely recruiting other vendors as well as individuals to and customers obviously to help with that. The initial release, so we have a GA product release now as part of Red Hat Runtimes, and that's certainly going to be more than good enough for most organizations. We already have many customers already running in production. What we're planning to do with the next release later this year is to bring in the native compilation element of Graal VM. So we can get those image sizes down even smaller, so image size on disk, and some improvements in performance as well for a certain class of applications. Not all applications will benefit from that static compiled to a native binary, but some applications will. So with the next release, we're going to support two models running on a conventional JVM with a lot of the benefits you get from a JVM, but also running as a compiled native executable.
Are you planning to keep Quarkus as a Red Hat open source project, or do you also plan to give it to a foundation?
If a foundation is a way to get more people involved, we will absolutely consider that. Again, we're past the initial phase of getting something out and in the hands of developers. The next stage is making this as broadly adopted as possible. And if moving to a foundation is the way to do that, then we'll do that. So it's certainly something we've talked about and considered. So yes, we would consider it.
How does it really help by moving a project to a foundation versus getting maintained by an individual or a company?
Yeah, so I do have some experience of this. I was on the board of the Node.js Foundation. Node.js for a long time was a single, what we call your benevolent dictator for life, where a single vendor really managed the project and governed it how they saw fit. As other organizations and individuals wanted to get more involved, it was obvious that governance was not going to be sufficient, and we needed to move it to a foundation. And with the aid of the vendor at the time and the Linux Foundation, we were able to do that. And as a direct consequence, we really grew the involvement in Node.js. So that's an example where a foundation has really taken a small project and made it essentially a de facto standard. So again, it's really depends on where we want to see the project go. And this is the kind of technology that does need to be ubiquitous. So we're definitely tending towards having as open collaboration as possible for Quarkus.
Also, at the same time, the fate or sustainability of the project is not tied to the success or failure of one company. Because if a small company, if the VC is involved, you really don't know. the license may be changed at some point. So it doesn't breed a lot of confidence within the ecosystem. But when you move to a foundation, you do know that these things are, instead of it being relying on just one company, it now relies on 5 different companies. And out of those 5 companies, 3 will still thrive or survive through whatever crisis that comes through. Or the foundation can take money from other areas and invest in that. So yeah, it does add a lot of to the sustainability of a project. Anything else that you'd like to touch upon, or do you think we have covered everything for at least this discussion?
No, what I say, so I've been involved in Java for pretty much all of the 25 years. I joined Sun Microsystems fairly on as Java was becoming popular. And throughout those 25 years, people have been saying Java's dead, Java's too slow. I haven't heard anybody say that for a while, so I guess we're past the slope of disenlightenment, whatever. Java's going to be around for a very, very long time. It's it's the number 1 or number 2 most popular programming language on the planet. There are very few other languages that can do what Java can do. There are between 7 and 11 million developers who know Java and are comfortable writing Java applications and very efficient writing applications with Java. What I tend to tell people, I said this 10 years ago at a conference, I'll say it again now. I suspect the last Java programmer hasn't been even born yet. It's programming languages, operating systems tend to stick around for a long time once they're established, because it's very, very hard to just change to an alternative. It's very, very difficult to do that. So yeah, Java's kind of middle age right now, and it's got at least another 25 years to go.
Yeah, I was talking to your colleague and friend from Sun Microsystem days, Aurelius Garcia Ribeiro, and he was saying, Java is kind of number 1 language when it comes to cloud, where the places it's running, people are not even aware of that.
Right. Yeah. Java literally runs everywhere, from cell phones to battleships and beyond. Yeah.
So once again, thank you so much for taking time out of your busy schedule and talking to me today. I mean, you're stuck at home. There's no hallway track, right? That's the one track that we are going to miss. But once again, thank you, and hopefully we'll see you. Everything will settle down, and we'll see you in person soon. Thank you.